Hello everyone, in this video we are going to talk about domain and range of exponential functions. Domain and range are critical components of functions unit. So in this particular video we are going to focus on exponential functions. So we are working on IXL Algebra 1 X.3 Domain and range of exponential functions. We are working with graphs. So in this assignment we are going to have several given exponential graphs, and we are going to decide what their domain or range are. So let's first talk about the concept of domain and range. Okay, so domain means, let's start with this, since the question is about the domain. Let's just start with the definition of domain. So domain consists of all of the values for x that makes the function possible or meaningful. So we're talking about all of the x elements, all x values that satisfy the graph or the function. But what does that mean? So let's just talk about this particular given exponential graph. And since we just learned that domain is the combination of the x values, all according to this graph, so now we know that we are talking about the horizontal axis and the numbers on that axis. Looking at the blue graph, for example, -4. If you are at that -4, you can go to the blue graph. You can find a corresponding point on the curve. Or, for example, like point 0, x equals 0, or x equals -4. It's not that easy to show it on -4 because the point looks like it's on the graph. It's not exactly on the graph. It is very close because of the dotted horizontal line. This right here is called asymptote. And it's horizontal. The meaning of this, if you want to learn about asymptotes more, you can click the link at the top to watch the assignments video to see what they do. But in short, they are your boundaries on the graph that tells you that the curve or the graph is not going to touch that dotted line. It's going to get as close as possible, but it is not going to touch. Those are the boundaries. If you have you can have more than one, they're going to limit your graph to go any further in that direction. So, which is why x equals -4 is not exactly on the curve. It's pretty close, but not touching that curve. But if you go a little high, a little up from that -4, you're going to touch that graph. Or take that x equals -0 as an example. So if you go up about like 1 unit, maybe it's like 0.9 or 0.957, but it's pretty close to 1. Whatever that number, you have a corresponding point on the graph. So x equals 0 should be part of your domain. X equals -4 should be part of your domain. Or take x equals +2 as an example. This should also be part of your domain because it has a corresponding point on the graph. Whatever that point is, we don't care what it is, as long as you have a corresponding point on the graph, that x value should be part of your domain. Or like all these negative numbers to the left side, so that arrows indicate that the graph goes to the left forever. It's not going to stop. It is going to get as close as possible to the dotted line, but it'll go on forever, which is why on the horizontal axis, left and right means your x values, the x values. If it goes to the left forever, that means all of these negative numbers up here, or like -100 or -1000, negative infinity, they're going to be part of your domain. All those negative numbers, because of that arrow. It indicates that it doesn't stop, it goes on forever. Same thing happens on the right side. Look at the right tip of this graph. It's pointing kind of up, but it's not exactly going up. It's going up and right. It's not straight up. Straight up would be a vertical line. Other than that, if you have a curve that's leaning towards like up, it's also going towards right. You gotta keep that in mind. This indicates that the graph goes on forever to the right side. If you have an arrow on each side, that means your domain is going to be all of the numbers, whether they're positive or negative. When I say all of the numbers, I'm just talking about this horizontal axis. I'm talking about the x-axis. I'm not talking about up and down movement. So this question is about the domain. If you're looking at the horizontal movement, left is obvious, it goes on forever, negative infinity. So all those negative numbers are going to be part of my domain. On the right side, that could be a little complicated at first, but this arrow indicates that it goes up and right forever. So since it goes right forever, it goes to positive infinity. Because if you extend this line over here, x equals 4 is going to be part of the graph. If you extend it a little further, x equals 8 is going to be part of the graph, and so on. All of these positive numbers are going to be part of your domain, which is why this question's answer is going to be all real numbers for the domain. All negatives and positives are going to be part of our solution. Now, let's move on to the next question. Or next level. Okay, what is the range of this function? We know that it is exponential because of how the graph looks like. These sort of movements are exponentials, or like this, or let's see. Yeah, these are exponential graphs. Let's see. We are talking about the range. Now let's just give the definition of range. Let's just clear this board up a little. Okay. Range's definition is pretty similar to the domain, with one difference. Instead of x values, we are going to deal with the y values. All y values that satisfy the conditions of the function. Basically, it means if it is part of the curve, if it is part of the graph, then it should be part of your solution set. It should be part of your range set. Let's see this one. Range is a little harder than the domain because in many of these cases, if you are dealing with an exponential function, range is going to be all real numbers. Like over 90% of the time, range is going to be all real numbers. I'm not just talking about this assignment. Or for this assignment, it could be 100% rate. When you have a question about range, it could be like 100% all real numbers. I didn't experience it. I didn't solve this assignment at all. But in reality, when you run into an exponential function, the range, domain is going to be all real numbers over 90% of the time. There are going to be very specific cases where it's not all real numbers, but in many occasions, it's going to be all real numbers for domain. Range, you're talking about up and down movement. See if there's any boundary that stops your function to go any further, up or down. Now, looking at here, we have a green curve. Right at the x-axis level, the graph stops because we have that dotted line. This is called the horizontal axis, remember? It tells the graph, it tells the curve to stop at that point. It tells me, do not touch me. It tells the graph to stop at that level. So remember, if the graph cannot go any further down, then the range cannot be all real numbers because the range does not have any of these negative numbers because the graph stops at this level right here. It cannot go any further. So the part of this range set is going to have all of the positive numbers above 0. Look at here. The green curve has a corresponding point over here. It has a corresponding point. Let's take this point. It has a corresponding point over there. 0 is not going to be part of this range because remember that dotted line is preventing the green curve to touch 0. Okay, so which is why 0 cannot be part of my range. The graph has no corresponding point at the 0 level. But as we go up high, like all these numbers are going to be part of the range. You don't see any other numbers at the top because the graph is not extended all the way to the to the positive infinity. It stops. We only have like a limited space availability. But if you extend that green curve, that indicates that the graph goes until forever. Range is going to have all those numbers up there, starting from 0. But remember, 0 should not be included. So let's just phrase it. All numbers, but all, this is for the y values, remember? If the answers have anything related to x, we gotta cross it out. There's nothing x related. Okay, all numbers that are greater than 0. So is it gonna look like this? Or is it going to look like that? Because if you just jump on one of the zeros that you see, you might get it wrong. This is wrong. Because that tells you that x is included, whereas it's at the boundary. The graph is not going to touch that 0. So the answer would be, I'm looking at this right here. Y is greater than 0. Now let me talk about what that expression means, because that might look a little complicated. That means, is that right? I'll explain what they mean. All of the y values such that y value should be greater than 0. That's what it means. That's how you read that expression. So that's how you decide what the range is. Let's move on to the next level. Okay, what is the range of this exponential function? Realize the first step. Decide whether you're dealing with a horizontal or vertical movement. Range is about vertical movement. Okay, this is vertical. And then it deals with the y values. That's how you can figure out whether it is vertical or horizontal. Y is up and down movement. Now just highlight the area that your function is in. So it cannot go any further from this point, right? It cannot go down. The 6, it'll get as close as possible to that 6, but it is not going to be equal to 6. So 6 is part of the range, and then it goes on forever. Like this area over here is going to be my range. And then I'm talking about up and down movement. Remember the vertical movement. That's going to be my answer. So starting from 6, y is going to be greater than 6. It'll go up forever. So as long as it's not equal to 6, as long as it is not less than 6, I'm fine. This is what I'm looking for in the answers. So y values such that y is greater than 6 should be my answer. Looking at here, that would be my answer. Moving on to the next question or next level. Again, range is a little trickier than the domain. Okay, what are the domain and range of this exponential function? Now, let's first talk about the domain. We have 4 options. We are talking about the domain. Domain is left-right movement, right? Okay, this is what I'm looking at. Is there any dotted line that goes up and down that limits my graph and tell it to stop, to go any further left or further right? I don't see any dotted vertical line. So there's nothing that limits my function on the left side, on the right side. Left is pretty obvious. It goes on forever. Arrow tells you that it goes on forever on the graph. And this arrow over here, while it looks like it's indicating up and right. Okay, it's up or right, it's going a little right, and then it goes kind of straight up. But again, it's not 100% straight up. So since it is even slightly going towards right, there's nothing that limiting this graph to go to the right. So all these positive numbers, including 100, including 1 million, all of them are going to be part of the domain. And likewise, all these negative numbers on the left side are going to be part of our graph, our domain. So looking at the domain, look at that green line over here. We are talking about the x values for the domain. It's all real numbers, all of the negative ones and all of the positive ones. So domain, all real numbers, domain, all real numbers. This one says x is greater than -8 or less than -8. -8 has something to do with the range, not the domain. So my answer is either the first or the last one. Now let's change the color and see what we can decide about the range. So I see that there is a horizontal line that stops my graph at -8. So it cannot be less than -8. It cannot be equal to -8 because the dotted line indicates that it's not equal. It cannot touch that -8. So, but it could be -7, -6, or all those positive numbers. As long as, like now, try to make sense out of what we have in the options. This one says y can be less than -8. So this answer tells me that y could be -10. It could be -12 or like -20 because all these numbers are less than -8. But that's not the case on the graph. Whereas this option over here tells me that y could be equal to -7. It cannot be equal to -8. That's what there's no equal sign underneath. -5, 0, 10, and so on. All these numbers are right. So that would be my answer. The last one would be my answer with the correct domain and range. And let's submit this and move on to the, I don't think there's any other level though. Okay. So basically that's what you're going to have with this assignment. So if you have any questions about determining the domain and range of a given exponential function, please comment below. I'll try to respond as soon as possible. Thanks for watching, and I will see you in another video.